Hey there, and welcome. All right, so today, we are diving deep into the genetics of eye color. We're going to decode the incredible science behind what you see when you look in the mirror and uncover how one of the rarest eye colors out there is actually a beautiful illusion.
Yeah, you heard that right. Just let that sink in for a second. The color that we all call green doesn't actually exist in your eye as a pigment. It's all a trick. A stunningly beautiful and complex illusion created by biology and physics working together in perfect harmony.
Okay, so if there's no green pigment in there, what in the world are we looking at? Well, it turns out it's this kind of beautiful genetic glitch, a phantom color that's literally created by your eye itself. So let's break down exactly how it works.
To really get this, you've got to stop thinking like an artist mixing paints on a palette and start thinking like a physicist studying light. Your eye isn't colored green, it's structured in a way that creates the perception of green. It's a huge difference.
So it really all kicks off with the physics of your gaze. The secrets to how your eyes pull off this color magic are hidden deep inside the physical structure of your iris and how it's built to play with light. Okay, so this front layer, it's called the stroma, and it is absolutely key. In most green eyes, it's almost clear. It has hardly any of the brown melanin pigment that gives brown eyes their color. And this lack of pigment is what sets the stage for the amazing light show that's about to happen. Now, there's a name for this whole phenomenon. It's called the Tyndall effect. See, as light enters that low pigment stroma, the tiny collagen fibers inside start to scatter it. But here's the thing. They don't scatter all light equally. They are just way better at scattering the shorter, blue wavelengths of light. And if that sounds kind of familiar, it should, because it's the exact same reason the sky looks blue. Little particles in our atmosphere scatter the sun's blue light in the same way. Your iris is just doing that on a microscopic scale. So get this, the base color we're actually starting with here isn't green at all, it's blue. But hold on a second. If the light bouncing around in there is blue, where does the green come from, right? Well, this is where the second piece of the puzzle, a little biological element, steps in and just changes the whole game. Let me introduce you to something called lipochrome. It's this microscopic dusting of a faint yellowish pigment that's also hanging out in the stroma. It's not green, it's not blue. This is our secret ingredient. It's the filter that's going to transform everything we see. And this is how it all clicks into place. You've got that scattered blue light thanks to the Tyndall effect. Then that blue light gets filtered through the faint yellow lipochrome. And what does your brain see? Green. It's literally that simple rule you learned in art class. Blue plus yellow makes green, but this time it's being powered by some seriously cool physics. And what's so cool is that this elegant little system also explains why there isn't just one green, right? You've got this whole spectrum from these light, icy aquas all the way to a deep hunter forest green. Tiny little variations in that structure create a huge range of colors. So take Aqua Glacial eyes, for instance. They've got these super fine collagen fibers, which means they scatter a ton of light. And they can even seem to shift between blue and green depending on the light. But then you have darker hunter forest eyes. They have a denser collagen structure, so they absorb more light, creating a much deeper, moodier, more solid, earthy green. And then you have the holy grail of green eyes, true emerald. I mean, this requires a perfect genetic roll of the dice. Everything has to be just right. The stroma's got to be clear enough to scatter that blue light perfectly, and it needs a way higher concentration of that yellow lipochrome. The result? A stunning, vivid, pure green that just pops in any kind of light. But, this incredible genetic trait, this beautiful lack of pigment that creates such piercing eyes, well, it actually comes with a trade-off. There's a hidden real-world consequence to having this amazing optical illusion in your eyes. So you have to wonder, right? Is there a downside to all this beauty? Is there a price to be paid? And for some people, the answer is a definite yes. Yeah, it's a condition called photophobia. And it's basically an extreme sensitivity to light. It's really common in those lightest shades of green eyes. Think mint or pale green, the ones with an extreme lack of pigmentation. And the science behind it is actually pretty straightforward. Pigment, like melanin, is fantastic at absorbing light. So when you have very little of it, your iris just can't block that incoming light very well. Way too much light passes straight through to the sensitive retina in the back of your eye. And that's what causes that discomfort, that feeling of needing to squint or grab your sunglasses, maybe even on a day that's not super bright.
So when you really think about it, your eye color is so much more than just a label on a driver's license, right? It's like a living document.
It's telling a story about the very structure of your collagen, the amount of pigment you carry, and maybe even the kind of environment your ancestors had to adapt to.
At the end of the day, what we just call green or blue or brown is really just our brain's interpretation of this deep, fascinating biological reality. It really makes you wonder, what incredible story of physics, biology, and history is written in your gaze?